Let's talk about the tangent line to a curve at a given point. Here we use a very simple example. Find the tangent line to the graph of f of x equals negative 2x squared plus 3x plus 1 when x equals 1. So the given point, when x equals 1, we replace x by 1. We could get the y value of the point is 2. So the given point is 1, 2. We import the SymPy. Now let's get the derivative f prime. We use this differentiation DIFF, this function from the SymPy, so we could get the f prime. The f prime is 3 minus 4x. We could manually get it. So here is negative 2 times 2, then x here power 2 minus 1. So it's negative 4x plus 3. F prime of 1. So 3 minus 4 times 1 equals negative 1. We know this negative 1 is the slope of the tangent line at the point x equals 1, y equals 2. Here we use the lambda-defy this function to evaluate the derivative at x equals 1. So we get the f prime when x equals 1 is negative 1. This is the slope of the tangent line at the point x equals 1, y equals 2. So this point. Now we have the point. This point 1, 2, not only on the function, the given function, original function, but also on the tangent line. And we get the tangent line, the slope is negative 1. Based on the point slope formula, we could get this tangent line, this function, this linear function is y equals negative x plus 3. Now let's go to the next cell. We want to do the graphing all three curves. So first, this one is our original function, this quadratic function. So we draw this graph. And the second curve is the tangent line. And the last one is the f prime. These four lines, we want to make the y and x axis in the middle, not on the side. And we also highlight the point, the given point, 1, 2, also mark all three curves. So we get this blue curve. This is from our original function. And this red one is the derivative function for this f of x. And the green one is the tangent line at x equals 1, this point x equals 1, y equals 2. And you see here this y-axis and the x-axis in the middle. If we delete those, now let's run again. So you see the difference, you would see the y-axis and it is not in the middle. Now let's go back. Let's run again. So you will see the difference. I just copy-pasted the figure here. Now let's explain. So this point is x equals 1, y equals 2. And this point on the original function, also on the tangent line. This point go to another point on the red line. The y value is, we just plug in x equals 1. So it's negative 1. Here is negative 1. So this point is x equals 1, y equals negative 1. The y value negative 1 is the slope of the tangent line of this green line at x equals 1. Now let's make another example. So if we choose this x equals negative 2, this point, we could get two corresponding points. One is on the original function, another is on this derivative, this red line. So here is negative 2x. And what's this y value? We could just simply plug x equals negative 2. So 3 minus 4 times negative 2 is 11. So this is 11. This 11 for this point on the red line is the slope of this tangent line. Let's draw. The slope of the tangent line is 11, is this point on the derivative, this red line, the y value. I hope this video helps.